G'day everyone, how you going? Quick video today on actually using differentiation by first principles to prove why the product rule works. The product rule, if you're not familiar, it's really when you've got two things multiplied together and you don't want to expand them out into one equation or one statement. You can do derivative of the first times the second plus the first times the derivative of the second, and that will get you the derivative of a function without having to expand it out. Now you might say, well, that's fine, and yeah, I've seen that, but why does it work? Well, let's think. If we've got this idea here, this is where we would probably use the product rule. Two functions multiplied together. All right? Now remember, when we want to work out the limit as h approaches 0 of a function, and I want you to see this whole thing here, that whole thing as one thing. When we originally did it, we only had one thing in there. Okay, we were working the derivative or the limit as h approaches 0 of one thing or one function. Now we've got two in there. So when I'm going to write that, I'm going to do exactly the same as what I did when I did differentiation by first principles, but now in here the first function or the first thing is the thing that has the plus h in it, and the second thing doesn't. Okay? Quick recap, I'll rub this out in a sec, but quick recap. If I have a function like this, and I have a point, say, here, and a point here, effectively I'm working out the gradient of the line between those 2 points. This one here, I would call x. This one here would be x plus h. Similarly, this would be f of x and f of x plus h. And what I'm doing is shrinking down that distance in there smaller and smaller as h approaches 0. So that's what I'm doing. But I'm doing exactly the same thing here, just with a different function now. So don't see it as anything radically different. It's not. I'm applying differentiation by first principles to a more complicated function. Now this is fine as it is, right? But I wouldn't be able to work that out. So now what I'm going to do is I'm going to add in here a little extra bit in here. So now I'm going to say the limit as h approaches 0 of f of x plus h times g of x plus h. Now I'm going to add in a little extra, and I'm going to check because I've got it written over here. I need to add in minus f of x plus h times g of x. And you might go, where did that come from? Well, some smart people long before us figured it out. I'm then going to say plus that exact thing, because if I add it and subtract it, then I don't change it. So then I'm going to say plus f of x plus h times g of x. And then I've got this guy here, the same. I've got minus f of x times g of x all over h. So it looks a bit complicated there, but can you see in the first two terms here, can you see how that and that are both in the first two terms? And in the second two terms, I've got that and that. So I've got some commonality in my first two and the second two terms. So now I'm going to say the limit as h approaches 0 of, bring this to the front, f of x plus h out front of g of x plus h times g of x. Right? And then, oh, hang on, I've got to put a minus in there, don't I? Because it's minus that. And then in the second one, I'm going to go plus. Actually, no, I think I'm going to go minus. It's going to be, no, I will go plus, sorry, g of x out front of. Take the g of x out front, I've got f of x plus h. I hope this is on the screen. Times f of x. Can someone just check that I still have that hanging on the screen?
That's good.
Are we good? Sorry.
Round edge.
Oh. Are we good? Can you fix that up so we're on the screen? I'll keep going. If you can fix that, that'd be great. So, all over h. Right? Oh, sorry, missed something here. It's going to be f of x minus. Yeah, it's going to be minus there as well. Oh, gee, this is not working out how I thought. What have I mucked up here? Say again. Start again. No, there's a step that I've mucked up here. I think I should be able to bring something out front now. Oh, no, we're good, we're okay, we're all good, we're good. So, what I'm now going to do... no, I've lost it. I don't know where I'm going with it. I'll check now. I have it on my phone, the actual little one of it. And there's something that I missed. There's a step. No, we're good at the moment. We're good at the moment. Okay, we're good. We're gonna split it up onto two separate limits. That's what we're going to do. Of this part. That's one limit. That H guy's up there. And then the second limit is going to be plus the limit of H approaching 0 of G of X times F of X plus H minus F of X all over H. Okay, we're on track again. This is good again. Now, the key thing we've got to now realise is that, see this part right here? See this part right here? Isn't that really just the derivative of G of X? Come right back to kind of our original, not this one, but the original idea of differentiation by first principles. Can you see how this is G of X plus H minus G of X divided by H? Well, that is exactly the idea of differentiation by first principles. So wouldn't that give us G dash of X? Right? And when H is approaching 0 in this part, isn't that just going to approach F of X? So when I apply this guy into here, this part right here just becomes F of X. And this part here in the green, doesn't that just become G dash of X? And if that didn't quite fit with you, follow through with the second part over here. I'll do a different colouring here. When I apply the limit as H approaches 0, oh, I don't need to here, I've got G of X. And isn't this F of X plus H minus F of X divided by H, isn't that really just the derivative of F of X? And isn't that, I mean, it might be the other way around from what you might normally say, derivative of the first times the second, plus the first times the derivative of the second, but isn't that just the product rule that we were told and used and went, hey, that works in practical examples? So with a little neat kind of add-in, subtract, add in, it allowed us to rearrange and then use the idea of differentiation by first principles to get that into something neat, that into something neat. I'll just change the colour coding here to match. And then really, this is exactly what I was trying to prove, to say that the product rule is the derivative of the first times the second plus the first times the derivative of the second. Now, should you be able to do that? Well, oh, look, in pure terms, sure, great. Will you ever be able to ask to do that in a test? Almost no. No chance whatsoever. It's about applying it and using it in practical examples. If you can remember that, fantastic. If you've got an idea where it comes from, great. But I wouldn't spend the time learning it if I was you. I had to look it up to remember the little trick down here about what we need to do. Hope this one helps. If you want some other ones, let me know.